welcome to Ask Klein Math for A.3D. Today we're going to talk about graphing the solution set of linear inequalities in two variables on the coordinate plane. Here's the problem we're looking at, and we're going to talk about which ordered pair is in the solution set for 8x plus 16y is greater than 32. First thing I'm going to think of is rephrase my question and reword in my own words. So the question is, which ordered pair is in the shaded region? For 8x plus 16y is greater than 32. So I know that the solution set means the shaded region. All right, now let's think about analyzing and formulating a plan about what information I have and then what I'm looking for. So the information I have is the equation. I have 8x plus 16y. I know that that graph is a line, so I know that I'm going to have to graph the line. And then I'm going to pick a point to test on one side of the line. And then I'm going to shade based on the true or false that I get from my test point. And then I'm going to need to check the points that will be in a list to see which are in the shaded region. All right, so let's get busy. The first thing I need to do is graph the point, graph the line. And in order to graph that, I'm going to solve for y. So I'm going to change that to an equal sign. I'm solving for the variable y. So to get the variable by itself, I'm going to first do the inverse of a positive 8x, and I'm going to subtract 8x. I'm left with 16y is equal to, I think I'll put the slope in front of the y-intercept. The variable I'm solving for is y, and I'm going to do the inverse of multiplication, which is division, and I'm going to divide underneath each piece of my equation. I'm going to reduce 8/16. 8 goes into 8/1, and 8 goes into 16 two times. So that would give me negative 1/2 x plus, and 16 goes into 32 two times. So I'm going to come over here and I'm going to graph my negative 1/2 x plus 2. Here's my y-intercept. Many ways to do this. I'm going to go up 1 and left 2. You could also go down 1 and right 2. And then since my equation has a greater than but not an equal to, I know that this is going to have to be a dotted line. Now I'm going to do that slope all the way over just so I get a nice line. And I'm going to do a dotted line. Oof. All right, at this point in my plan, I decided that I was going to use some test points. So the easiest point for me to use is this 0, 0. I'm going to check to see if that is in the shaded region. Now there's a couple of different ways to do this. Since my equation is right here, I'm going to go ahead and plug in 0 for x and 0 for y, and see if it's greater than 32. That gives me 0, that gives me 0. 0 greater than 32, that is not true. So this x and y coordinate that I've chosen is not in the shaded region because that is not true, so then I would shade in the region above. All right, so my next step is to check the points, and I've got these points listed right below here. 0, 2 is on the line. It's a dotted line, so that is not in the shaded region. Negative 3 and up to 5 is in the shaded region. Negative 1, 1, left 1 and up 1 is not. And again, 4, 0 is on the line, and since 4, 0 is on the line and it's dotted, that is not part of the shaded region. So I believe that B, negative 3, 5, is the point that would be in the shaded region, which is the solution to the inequality. All right, now let's think about if that is a reasonable solution or not. I have extra space right down here. There we go. And if I talk about which of the ordered pairs, so then I would say that the ordered pair negative 3, 5 is in the shaded region, which is also called the solution set. All right, now I'm going to justify my answer. You know, just a few minutes ago, when I solved for y, I had that y is greater than negative 1/2 x plus 2. So another way of doing this would be to check each of those test points that I used and compare them to see if it works. So I'm going to check my points, negative 3, 5. My x is 3 and my y is 5. So I'm going to plug in 5 is greater than negative 1/2 times negative 3 plus 2. So that would be 5 is greater than, negative times a negative is a positive. I could write this as 3/2, or I could write it as 0.5 or 0.5 plus 2. And now I have 5 is greater than 2.5, and it is. So I have just confirmed my answer to make sure that it is in the solution set. I believe that my solution was done in a good, efficient manner, and I checked it, and hey, we did a great job. Thank you guys for joining me for Ask Klein Math. Have a great day.